Dwie sprawy organizacyjne. Pierwsza, ja nie potrzebuję, chyba mnie słyszysz, prawda? Wiesz co u Ciebie się za tydzień dzieje. Tak, znowu jesteśmy my. Ja tutaj będę przez całą imprezę i będę mówił o Kopolu. To jest jedna rzecz. To jest 99. spotkanie. Jest spotkanie numer 100, które chcemy zrobić trochę niespodziankowo, ale musi się pełen skład organizacyjny spotkać. Jeżeli macie jakieś fajne pomysły, to na grupie możecie wrzucać, szczególnie jeżeli chcecie mówić albo nie. My jesteśmy otwarci. Zobaczymy, co z tego wyniknie. Chyba z ogłoszeń parafialnych to na tyle. Na koniec losujemy licencję, tak? No, będzie coś losowane. Generalnie, jeżeli się zapisaliście, to macie szansę coś wygrać. Jeżeli się zapisaliście i nie przyszliście, sorry. Dobra, pytanie, czy możemy zaczynać?
Jeszcze sekundę, sprawdzę, czy tutaj widać.
Widać.
My Cię widzimy.
My Ciebie widzimy, więc jest dobrze. To ja tak już delikatnie się usuwam, mnie nie ma. Dio, do zobaczenia za tydzień. Będzie się wymienić dość.
No od jesieni w końcu obiecywałeś ten koła, w końcu będzie bardzo.
Ja tego koła obiecywałem już 2 lata. Sprawdź ten zerwoj się.
Dobrze, ja słyszałem od jesieni.
Co?
Ta komoda.
Cześć. Ktoś nie mówi po polsku? Dzisiaj.
Zadanie tego pytania po polsku jest.
Right, is there anyone actually out here who doesn't speak Polish? Right, that settles it. It's all in English now. Okay, first of all, there is an application here. It's called Kahoot. Who knows Kahoot? Great. You can download it on iOS and Android. It's a game, it's a quiz. So along with the presentation, there will be also a contest, a quiz. The first prize is a book called Docker Toolkit by Fabrice. He's a really good guy. I mean, previously he wrote a book on Docker Swarm. It was really good, and this one just appeared like 2 weeks ago. It's really nice. So if you want to take part in it, just download the application and enter that game pen. Right, maybe I'll start. So, first of all, sorry, if you have any questions, just ask straight away. Let's get started. So, I'm a software engineer. I work for a company called Perkowski. I've been programming in Spring Boot since Spring for 12 years now. With Docker, I think 4 years now. I did a couple of migrations on a couple of different projects which used either just Java or Spring MVC, Spring Boot. And along those lines, actually I've learned a couple of things that are really useful in terms of what to do, not to mess up. So Perkowski is a small company doing software for airline companies. We do entertainment systems, like something like Netflix for airlines without the internet, with the internet. We're actually providing the internet for our customer. And we do software for pilots. It's like whatever they have on board, we provide it. So the agenda is, first I'm going to introduce like the two members of that presentation. It's Spring and Spring Boot. Then I'm going to say a couple of things about Docker itself. I'll show you some of the things I recently did, or what I recently did with the migration of the last project I did. And how to write like a good container, a good image, and also how to create like a good, nice, fast, continuous integration framework which actually can, help you build these Spring Boot applications. So just for me to adjust the meeting, it's how many people actually here use Docker? Raise your hand. Good. How many people use Docker on production? Okay, production. All right. Okay. All right. Okay, and let's get things straight. Like Java 6, Java 7, Java 8, Java 9.
It's like Windows 9.
10, 11. Okay, never mind. Okay, let's continue. So, first contestant, Spring. Spring is amazing. I mean, it really is. It's been here for what? I mean, years now. Geez, it's 2002, right? It's like 16 years. It's a teenager now. So, it's amazing, right? I mean, the number of tools which have been integrated, across the years, it's mind-blowing. It's like, Spring Data, Hibernate, Elasticsearch, Solar, whatever have you. It's like dozens of those. And with that dozen, you actually get also, diabetes, because it's actually overgrown. Like it's just tremendously huge. So with that, I'll do like a first question. So we have a couple of people lined up. 4 people, not 14 people. Okay. So first question will be a test question, just for you to see how it works. So here it goes. Let's give it a start. Let's see if we'll see anything. Okay, it's a test question. So what's the age difference between Java, when it was created, and Docker? So 4 answers are 12, 15, 18, 21. You're supposed to provide an answer. Time is 15 seconds. That's the time for me to get some fluids. Okay, and yeah, it's now something like 18 years, like the difference, right? Because like Docker was created like around like 5 years ago. So there's one answer like that, which is good. And I just mentioned like the number of the libraries which are integrated with Spring and Spring Boot. So I'll just add like another question about that. Okay. Oh, that's not the question. Sorry, like who knows pet planning? Right, it's the sample application for like Spring and Spring Boot. How do you think, like how many exceptions does it throw on startup to get things going, like, just silently? Just, 10, 1,000, like 32,000, or like 64,000? Silently, behind the lines. Yeah, it's actually around like 64,000 exceptions. So you can get the idea how it works. Opening jars is bad for you. So let's continue with the presentation. So like, what's the competition for Spring? There's a couple of those. There's Play, right? I mean, Vertex, Rails. JSF is also there. I mean, I was surprised. This is a summary from Zero Turnaround, and it like shows like in terms of like popularity like across like Google, LinkedIn, and all the other like systems, what is the most popular one? I'm actually surprised to see JSF out there. I mean, it's
standard.
yeah, it's a standard. Come on, nothing changes in the universe. Some things are constant. So you know, like Spring Embassy. I mean, I'm not surprised at all. Spring Boot gaining popularity. 5 years. That's a long time for it to be here. And there's like most of them like of the applications out there. And you know, like Spring is the glue, right? All the other frameworks need some kind of a dependency injection, something. And this one has it all, right? I mean, geez, it's like a master framework for it all. I mean, whatever have you. It's like it's good for like monoliths, for small projects, but it's advertised like for microservices. Okay, but I like it. I'm nagging, but at the same time, I like it. If you're looking for people who actually will work with Spring, it's really good. I mean, Java specifically, actually. So, Spring is the standardized way. Spring Boot is the standardized way of providing applications nowadays. Nowadays, it's 5 years old. It's like it's easy, right? It's not simple. It's like it has the luggage with it. Like those 18 years are still out there, but it's easy. If you want to create like a simple application, I'll show you in a sec. It's like that simple, and it's fresh. You just click a button. Like one command. There are like different tools for creating like a template for applications, which are really like nice. It's really good for that. Now, there are like Scalatra, like things smaller, like which are more agile. But that's really good. Now, on the other side, we're supposed to talk about Docker and how to mix those two. And Docker has been here also like for 5 years, I think, and it makes a huge difference. I would say. I can say that at least it makes a huge difference to me. It uses like the kernel features to actually provide new functionalities which were previously known, but now it's like on a new level. Like the creators of actually Spring say that the overhead of these solutions is about like 8-9%. That's usually sometimes it's connected with the fact of those union file systems. But it's and the other one, and the separation of the processes. So it's like that's a standard comparison like people make like between virtual machines like VMware, VirtualBox, providers, and Docker. It misses like that additional layer which actually creates the whole system, like keeps in memory all the things needed to actually have a new system like in memory, and that that adds overhead. And on the other side, Docker is really really lean. You can create like small, my way of thinking, like processes which are really good. So some idioms out there like for things that are that we have to have in common, like when you think about like Docker. There are images, right? I mean, when you think images, like entity of images, we mean like small, right, jars. When we think containers, like processes, I mean, something that runs that image. It can be stopped, but whatever state, but it's actually an instance, running instance. And then there is a service, an entity, an idea added by Docker Swarm that is actually that gives you the higher level of abstraction, how to actually create a set of containers, groups, and really. Okay.
Is it better now? I'll continue the song. Okay. Do you have any questions so far? I know I'm going really fast, so I'm going to slow down now. Any questions?
Good. All right. So there is a number of like orchestrating systems out there which you can use, like systems which actually provide you a way to link individual containers, to have them running across like different clusters, to have them like associating like resources specific to some different providers, and
the most popular ones are Docker Swarm. Anyone using Docker Swarm? Okay. Kubernetes. Anyone using Kubernetes? Here you go. And AWS ECS, which is also popular. It has some issues of its own, and it's like lagging a bit behind, but it's at the same time, the integration of AWS resources is great, but it's expensive in comparison with those two first ones. So I think I'm going to show you, like last month, there has been a tool released for creating applications, for creating the whole continuous integration pipelines. And it's actually using the middle one, Kubernetes, and it's really good. I mean, it's really simple, so you don't have to. It gives you the assurance that you don't have to know everything about Kubernetes, because Kubernetes is the most complex one of these all, and it's actually the most stable one. Like I used like Docker Swarm for a long time, and I love it. But at the same time, it has issues, stability issues. Like for 3 months, they couldn't fix it.
It has issues.
It has issues. I hope it doesn't bug me up. Okay, let me just see. So there is like that tool is called like Jenkins X. Like who uses Jenkins? It's really good. I mean, it's like, so it's a tool which actually runs on Jenkins itself, and then it hacks it up, like uses tools specific to Kubernetes, like Kops, Helm, and all other tools. Then it actually combines that with repositories, like keeping like the state of like individual environments in specific repositories, like on GitHub or Bitbucket. It creates that all itself. So out of the box, you can get like a Jenkins. Completely like distributed, like where every single worker is actually created as a new process, as a new container, like in Kubernetes, which is really cool. And let's take a look. So it provides like a standard like client. It's called JX, and it's just brew install JX. So it's wherever have you a apt get and so on. And what do you do? Well. You have a couple of commands, like context, which is like the application that you're using at the moment. And it's if you install that, you can say, for instance, you can say JX create a new cluster, and then just in the Google container, Google Kubernetes, and cluster. And then, that will actually create your cluster. It will ask you for your permission. Will show your email, something personal. And then it will ask for the consent. And, okay, it will say, I think I already have one. It will ask for a project. It's like really keeps you, one step at a time. It's like really simple. You have to have permission to actually run to have billing assigned to Kubernetes, like in Google. So I'm going to select just one project that I have, and I think it will fail because I have already one created, and I have like 3 tier, which is like just 8 instances, and so. But anyway, I'll create like let's say something in Europe, and then I'll say, okay, I want 3 nodes, 5 if something happens, and then just go ahead and create one. It will fail, but I already have one created. Yeah. And it's probably the limit is bad. Oh, well, let's wait a bit. Okay, let me see. Yeah, okay, let me just say, I play with it a bit. So I can say JX uninstall. In the meantime, we'll uninstall it. Like creating of the Kubernetes cluster takes a while. I'll just connect with Google Cloud to clean up the resources out there, because it doesn't do that automatically. I mean, it doesn't want to delete your cluster. So, let me just do that in a sec. Go to console.
Kubernetes. Where is it? So it's like, you know, if you don't know like Docker, there's like multiple tools out there. There's like dozens different like ways of running these containers. This is one of those. Like Google provides really nice environment for running those. Now it says that actually I have a running cluster here, but I stopped it when it was being created, so I think it's dead to me now. So I'll delete it and I'll just wait until it finishes. And look for that too. Helm delete purge. Exit status. Wow. Okay, let's wait for that to happen. And let's get back to the presentation. The last platform I actually migrated was something like this. I mean, it's simplified, but you know, you'll get the idea what it does. So it's a set of like different different processes. You know, there is like every single time there is like a separate UI which runs on Nginx. It's really good, and it's like a it's like a static single page application. Then it stands in front of the backend application, which is usually something on Spring or Ratpack or something like that. And then it connects to a database. So it's like I think it's a standard way of like years ago, applications were created like that. There are some additional tools. Redis, Elasticsearch, like that uses AWS, S3. JMS is there. I didn't connect it because the lines would go everywhere. And then there is a front-end proxy, which is like the Nginx or something, which actually routes the traffic along these different applications. Any questions so far? Okay. So all these applications were created like with different tools, right? GWT. Good. JSPs. Good. Spring MVC. Just Spring MVC. Okay. Spring Boot. All right. Okay. So what are the issues with those? I mean, those are, if you want to create like an application, if you want to unify these applications, have like a one framework to hold them all and then darkness bind. You have to do extra things for GWT and for JSPs. If this doesn't work out of the box, it just you just need things like tools jar or like something which will compile GWT a couple of times, permutations, therefore. And there is like a Spring MVC, which is quite straightforward, right? I mean, you create like 5 XML files or like Java config now, and then it's there. And on top of it, you have like Spring Boot, which is good. So, so we were thinking like what to do. So we were like we had these applications which had enormous amount of like config files. So I'll the demonstration how that looks. So so let's say you want to deploy that set somewhere. So what do you need? Let's say you have like 5, 6 customers, like a couple of standard like environments like QA, staging, production, and some other ones. And then you have that set of like these 4 applications. And apart from it, you have UIs for those applications, like something that provides these static pages. So how do you do that? Well, how that was done so far. You go to like one of the clients, for instance, I don't know, client 1, and you have the configuration per one application, right? So you have, for instance, application counter, which holds like Nginx config, some startup conf, which just holds some standard configuration, where to create that application, some standard options, what happens if it dies, some profiles. It's standard things I think.
And then, you know, like some startup script, which is quite simple, simplified with, you know, doesn't deal with situations like zombies and so on. It's you know, something. And then on top of it, you also have, you know, application properties or any other properties specific to the framing that you're using. It's like, it goes on and on. And the way that it was done previously, it was, you had to have, like, okay, that set multiplied by the number of customers and, well, actually by the number of, like, different environments. So, you know, you end up with that list of files that you have to do something with. It's just, you know, it's not easy to keep track what's going on here. It's like, you know, it keeps going on and someone says, you know, oh, please migrate your configuration from that host to the other, and it's like, I'll do it. I'll compare those you know, directories, you know, I'll do it someday. So we were thinking, okay, so first things first, right? Let's limit duplications, right? So let's find a way to say, let's not duplicate these application properties, because previously, you know, someone thought that it's a good idea that if you place these properties and they'll repeat every single time just to be sure that they're overridden for specific applications will be good. But, you know, if you want to compare them, that's madness. So, you know, we extracted just the diffs, right? We created like a standard like setup, which would be reference setup, and then on top of it, we would build overrides for specific environments. And, you know, that list, which was actually, you know, the whole list was like 100 properties, was, you know, was reduced to, I don't know, maybe 3 like different properties, which actually hold it like DNS entries for like other services. So not bad, still could be better. So then we were thinking, okay, fine, what to do with that? Okay, let's start. So we reduced the number of like these properties, and then when that happened, we started introducing like Docker. How do you introduce Docker? Where, you know, per service you add that Docker file, you add some, you know, Jenkins configuration if you have Jenkins, and then that's it. So that thing here, we moved to like a new infrastructure, which uses actually Docker Compose. Docker Compose, it's like a way of orchestrating, but it's actually limited in a way that, you know, people use it for like one host. It's like, you know, you can use it locally. It specifies a format, which is really good. That format can be used for other like environments. It could be used for Docker Swarm. It could be used for Kubernetes, but you have to convert it. So what we ended up with was like, let's say the same structure, only the difference is that we have the default, and now for specific environments, you know, the only thing that we have is one file, which holds actually the configuration, the overrides for that specific environment. So, you know, we replace these, you know, dozens of like different files with a couple of these, and it's like, it's really concise that one file holds the soul of that environment. I mean, whatever creates it. So, you know, you would say, let's see what's in the client one Docker Compose file. It would say, hi, my name is Kander. I'm, what says it's me, it's the fact that I have the database somewhere in AWS RDS, because you can create a container which says, like, which holds MySQL inside of it, which is really good for like development. But if you're in the cloud, you know, you want to if you don't want to have like your own containers manage MySQL, have some kind of operations tools which will do that, well, you can ask AWS and use their resources. It has advantages, disadvantages of like, you know, thousands of dollars spent for those small, tiny instances which can hold like, let's say 150 connections at a time. That's what you get. But you know, this one file specifies it all, like, right? So it specifies even like more than the previous setup. So it says, for instance, you know, just bump up my memory usage because, you know, I'm hungry. Then it says I want 10 of these containers started up, and then it has, you know, like specific settings for that Elasticsearch, which it says also I want to use that amount of resources.
So it's a really concise way of saying that. Now, obviously, that means that the defaults have to be adjusted perfectly. So the defaults are, they don't look that good. They don't look bad at all. So the default specifies, for instance, that there is some kind of a front proxy, which image is specified by that URL. It's called a URL. It's like a image tag, and it says just what to run, like what kind of, let's say, equivalent of jar do you want to run, and then it depends on these different services. The depends on is problematic because it's not used with some orchestration tools. But in Docker Compose, it allows you to actually start all these services at once. If you say you want to start a front proxy, it will start all its dependencies at once. Now, apart from that, you're also saying, what's the definition, like the reference settings for like all the other services out there. So one of those is Pillar. It has an image of its own, copied image of its own. It specifies like common settings, like where the broker is. It specifies some options which you have to specify in Spring Boot, not to initialize twice the logging framework. And it specifies also like additional setup properties which you have to specify to handle like forwarding of headers and so that the request is secured. And for every single one of these services, you create a configuration like that. Sometimes it's more complex, like the one on the bottom, like this one. For instance, you can say specific things like, how do you want to restart it, right? So, is it supposed to restart at fail? Is it supposed to, wait and start up? Maybe there's something else which is supposed to start and you want to just wait with it because it won't start. Then you have the help check, which is just how to check for Docker if that still works, how many tries to retry it, and so on. And you have these images for like UIs, for Redis. Just something. I know, like, is anyone missing here? Something here for Redis? Tons of options for Redis cluster. But this one actually, makes it going, right? I mean, you can create it, you can use it locally, it works perfectly. And like something that starts Elasticsearch, right? You can say how many instances are there, how many replicas. I think you have to decide who's the leader, but I don't recall exactly. And you can specify some really low-level system like limits, how many open files, memory, and so on. It's really good for that. Now, on top of it, right, you want to have like some reference implementation, for instance, for database. If you're not using like database which is somewhere in the cloud, you can use container, which is really good. It's really lean. We use like every day like a couple of these database instances, and if they work fine, like not clogging the whole system, it's really good. At the same time, doing that, if you have a specific like instance for the database, you can kill one and the rest will be there. It doesn't matter at all. So the idea was that we transformed to Docker. We transformed to like first remove the extensive configuration, then we moved to Docker, or to Spring Boot, and then we introduced Docker, and that allowed us to have that really concise configuration here. Other things, which is actually good things about like introducing Spring, is the fact that it allows you to easily create configurations locally, which previously were hard. I mean, previously there also like existed tools for doing that. It's just the fact that like this one is really precise. So like one of the things, how you actually modify the Spring Boot application is that you provide profiles, right? I mean, that was the thing of the past. I mean, for the first time when profiles were introduced, I thought that's a brilliant idea. And then like an hour later, it was like, wait a second, how am I supposed to test that? I mean,
every single time I'm supposed to test, I'm supposed to kill the application and start with a separate profile, and then again, and again, and again. Okay, so usually what people do is they provide one configuration, and they say, that's for Redis, that's for the cluster thing, and that's for local environment. And then when things start happening, because the differences between your development environment and production start to grow, it just becomes unbearable. Where you could and it all comes down to the fact that you don't want to say to people, hi, you're a new guy, right? Install the whole application, the whole platform now. And then suddenly the guy says, okay, what I was supposed to do? I have the reference manual here. And you just start and say, okay, install MySQL, install Elasticsearch, and so on. And when you end that book, you know it all, right? You have the broad perspective of the application, right? You could write a book on it yourself. Where it's not what you want, right? You want to have like a system which says, please start. And then I'll tinker with just one component, and later I think about the rest, right? Just make it start. In Docker, you could say, I could just remove that profile, just test one specific version, one specific variant of the application, and just, create that one container, right? Which does Redis. And then, that name, that service, Redis, will be registered as a DNS entry. So you just say Redis, and it works. So that's the way you could solve these problems. So what kind of problems actually does Docker solve? Well, I didn't know where to start. Think about that. So this is like, what kind of problems does it solve locally? So even yesterday we had like 2 new people coming to the team, and we were thinking how to keep them going, right? Just start the application. So previously it would take, hours, days, until they finally said, I set up my application. And it's just like, great. And nowadays, you just most of the time it's actually spent setting up, corporate access to different resources, like the private repositories for Docker images, or access to the network and so on. So it really simplifies the way you're thinking about your application. And if these dependencies are complex, like Elasticsearch, JMS, whatever have you, it's just you just start and you don't even know what you started. It's out there on the list. It's somewhere out there working on your local machine, but you don't see it unless you're using it. So it minimizes actually the differences between development environment and production. It brings that production closer to you. And it's and it simplifies also configuration, right? You can use Spring Boot relaxed bindings to actually say that all these properties with dots are supposed to be replaced with environmental variables, and that works really well, for overriding, for the overrides for specific environments. And it's portable. You can have working like a Max with the use of VirtualBox, or there's a couple of months ago, even a lower level, the integration with Mac was provided. Same with Windows, and Docker for Windows is right now really faster than what it was with the VirtualBox. And on Linux, it just works. So we ended up actually, when we did that, we ended up with a really thinner layers of that application. When someone calls different resources, it's right now it's that front proxy, which is not something you explicitly say that it's 1, 2 instances. You can say in all the cluster, every single node, for instance, might have that, and then due to the fact that every node in the cluster, for instance, in Spring for Docker Swarm or Kubernetes, knows about all the others, the other nodes. You can route them. That's Docker Swarm specific. So you can say, for instance, that the front proxy is supposed to be installed on all the nodes, and then when it asks you for something, for a specific resource, like a counter, it will go there from each of these nodes, right? So you don't have to think okay, this node can only talk with this one, right? It's really good. The isolation is on the container, on the service level. Any questions so far?
So are you actually able to run this whole thing on your local?
So we usually, yes. Yes, it usually, if you start like MySQL and all these services, that's really good. Once you get to like Elasticsearch, it's just, Elasticsearch just keeps doing things like in the background. Or like, we use also like Apache Niffy. Anyone using Apache Niffy? It's a pipeline for doing things like, yeah, so it's like you can have some workflows which specify, for instance, for us, it's like, when we take specific document, how does it get to Elasticsearch, and it's indexed somewhere in the background. So it's a pipeline. And at the same time, it means that it's really just makes your computer die. So if you have like a Mac, which is like, limited to 16 gigs of RAM, it works, but you won't be happy about it. So, like that doesn't make it that much difference. But at least like the access from the front proxy is specifically to these containers. The front proxy might be an implementation, for instance, of Docker Flow Proxy, which is a project created by one of the Docker captains, and it's like really good to specify the routing inside of your cluster. Okay, so one thing is like how to get started, right? So once you think, okay, but you provided me with these examples, high level, how you did that, but how do you get started? Well, you go to like Spring Boot Docker, Google Spring Boot Docker, and it brings you to Spring Boot page, which specifies that you're supposed to create that one file, and it should be running, right? I mean, you just do that. So how does it work? Let's see, GS, oh my god. So this is like the complete version. Like they're saying, just create that file. It's supposed to have just that. And then, in the Gradle, full Gradle, you're supposed to add, those couple of lines which say, I depend on the, creation of the jar. And then, my name is that whatever is out there. I use just the file, the fat jar, the one that makes you sick, and then it just pass that the address to that file to my process, Docker process, and if you run that example, right, it will just create you like the whatever simple container. So you do that by saying build Docker. The example is quite straightforward, and it starts, Gradle, and it builds the jar application, and I have Docker running here on Mac. It's quite okay, and right now it will start using my 3G and start downloading OpenJDK. Alpine is something like 40 megs, which is really like small image, but it still takes a while on 3G. Hopefully you will just finish. Any questions so far? Yes? And these images. Good thing, right? That's yeah. That was taken actually from Docker, Spring Docker example, but I would also use like JRE just so that make it a bit smaller. Okay, so finally you're finished. I was downloading these images, and they're actually quite small. You can see how small are they. So you can list like different images that you have. So that was the 16 seconds ago. He built like one of these images, and you can take a look. You can say like Docker history, and it will tell you the size of it, like the whole size of it, that thing. But you can also ask it to say okay, so what did you actually do, right? I mean, what was behind that specific image? And it will tell you that it created that Alpine that was 4 megs, and it executed a couple of environmental variables, setting up like what version of Java does it want to compile, and then it added Java, 97 megs, and then you'll see that 60 megs, so I'll just use that, 60 megs, and then that was your application. Okay, what's wrong with that? That's a default example, it appears everywhere. I'll show you the application. Okay, let's see. So that application that's a one-class application, application Java. And that one application is just that, 16 megs of data, just to have that one class, right? I mean, that's a bit extreme. I mean, it's how come? I mean, 16 megs. So, you think that, come on, every single time someone will have to download that, you will have to download these 16 megs of data with every single change. Someone puts a dot inside of that file, and here you go, 16 megs downloaded. Think about the fact that this is like a small application with one class. Usually, I'm not sure how big are your applications, but usually I see applications, people come up and say, well, our application is a large 200 megs fat jar. And that's, you have to work with that. So every single time someone will actually use that image, he would have to download 200 megs per application. So if he comes back in the morning and he wants to download the whole platform, which is like, I don't know, 10 services, he'll have to download like a couple of gigs of data. Every single employee. That's madness. I mean, even private, like, proxies, like repository proxies, won't help you here. So how can you overcome that? Well, you have to build a better image. But before I do that, I'll just take a look at that cluster of mine. And I'll say, please create my cluster, because I just deleted the one that I had. This tool actually allows you to, it integrates itself like with Kubernetes on Google Cloud, AWS, and you can also have like local installations of like Kubernetes. Oh, let me just select that again. And again, that same thing, and 3.5, and that takes a while because it's supposed to create the cluster now. Well, maybe let's wait until he says he finished. Anyway, so going back, so how to create a better image? Well, you can create a better image, sure. So the problem with those 16 megs is actually that when you build that image, you're actually using a cool feature of Docker, which is like a build cache. What it does, it allows you to use a feature called like layered file systems, where you can say that every single command adds some files, and until you actually a step of these actually modifies something, so that moment you're using the cache, right? So you can say, for instance, that if nothing changes to step, I don't know, the last step, you'll use the cache and you won't actually create a new image. You'll use the previous image, like which was already created, because the cache will be used. And this image, what it does, it actually extracts the fat jar, and it says, okay, first, download all the client, all the client jars which you provide, and then first install those. Usually, for instance, for the applications like monolith applications which use eCache and other things, huge things, it actually saves hundreds of megs. So you first build, you first add those 100 megs, and at the end you say, my classes are here. It's not here. Not here. My classes are destroyed. Oh yeah, here you go. And it says, okay, so copy all these libraries, and then copy my classes. So usually, if you change that one class, only this part will be executed, and then this part here. Well, but these guys are just modifications to the environment variables. We usually add some of our own variables because they're really good for you. we usually say that, the default Java apps are, let's say things like that. And then we say, and if you have customers which don't use Docker and say that they can use Docker in 3 years because they use Red Hat 6 and never mind. So you actually get you can give them these images, or you can add them the same concept in their the previous way of shipping their application, and you can say, okay, I use the same application everywhere, the same options. I have some defaults run on every single environment, and if you have some modifications, just put them here, right? So at least it visualizes these differences, that there are differences, and you're not overriding these defaults every single time. So how does that work? Well, so let's take that in. Here we go. Let's just wait for that guy. So he says, should I install ingest controller, something that actually just processes incoming messages, incoming requests? Yes, create one. And let's wait for that guy. Sorry, I wanted to go here. So let's go to just slightly modified example. So this guy has those modifications, right? It has the these options that it splits out that initialization. What it also does, it also just there has to be some modification. So that's the notification where it says, oh please unpack my bad jar, copy it here, and just use these files in that extracted directory. So that's the only change. And the difference is that if you build that, let's say, I'm not sure why you use clean, it should work. Build Docker. Actually, right, Docker also has a build. Here you go. That was built. They used actually partially the same build cache up until the point where it met any change. So what you can now have, you can say, okay, that new image that doesn't look successful. I don't see it. Let's see what happened. Oh, it actually finished. Okay. Oh right. Take a look at that guy. Ah, yes. I was wondering why he didn't do anything. That should do something. So if I'll ask the guy, so what have you inside? He will actually say, okay, now those 16 megs are gone, right? So he said 16 megs are here. Those are these top, common libraries for Spring Boot. Like anything out there, right? Docker, Spring Boot, Spring Context, Spring Beans, Spring whatever. And then, just afterwards, that's my class, right? So that's 1 kilobyte. So I right now reduce the size of my image to 1 kilobyte and some copying the fact that some kind of directory exists. So, right now, if I'll ship that and I'll have tens of these applications, and someone comes in the morning, he's not downloading gigabytes of data, he's downloading I don't know, a couple of megs maybe, if you're doing actually more modifications in one class. And you can live with that. That's really good. So that brings the question another thing, what can you do with that? Well, you can first take a look at the cluster, what happened with it. Yeah, so he asks for a domain. I'll create the default domain. Do you wish to use your, again, exposed private credentials, like on GitHub? Yes. And I already did that, some of it once, so he asks whether he's supposed to update those. Okay, so he's cloning. So he's adding now different repositories. He's just managing, recreating my repositories on GitHub. And let him finish. He's using right now Helm to install some of the common dependencies. and I got lost. So yeah, we were supposed to just go back. So what can you do with it? Well, how many of your applications actually, when you have fat jars, who have fat jars providing them somehow? Like you actually cross the boundary of 100 megs per fat jar. So don't be shy. I know it's out there. Come on, I would raise my hand too. So it's like a, so we have a common problem, right? Whether to provide snapshots or releases, like right, I mean, the whole files, right? Whether to go with the route of these continuous delivery, create every delivery which is exactly the same way, and not providing snapshots, right? But the snapshots on the other hand are really easy to delete, so it's really good. But once you have to store them somehow, every single build keeps a couple of hundred megs, and then after a couple of days you say, well, the Nexus or Artifactory is gone because it's just wasted, wasted space. So what you can do actually, you can say, fine. I mean, I'm not deploying to Nexus at all. I'm keeping my application in the Docker private repo, and then if someone wants a jar, I'll create you one out of that image, right? So I'll say, I had my image. I create a container. I'm not even starting it. I copy all these files from that container to some kind of temporary directory. Then I remove it, and then I pack it all up into a nice jar, and I provide my customer who doesn't want to use Docker. Fine, if you want to go that way, sure. So this saves you a huge amount of memory because you're keeping just the delta, that 1 kilobyte, right? Any questions so far? Okay. So, who knows actually how the Spring Boot jar file is created, like the executable. It's amazing. I mean, it's really amazing. I mean, it's not rocket science at all. It's like if you play Wolfenstein, Return to Castle Wolfenstein. The same trick was out there. That you downloaded 1 gig SH file, and then you had the script like up front, right, which just was saying, okay, unpack the rest of that file, where I cut off the first part and then I extract it all. So Spring Boot does the same thing, but then like Spring Boot also has to extract some of the resources, like JSP files, or like some, like if you're using Jersey, for instance, right? You have to unpack it first because they cannot be used inside of the fat jar. So Spring Boot actually has a way of saying, okay, create a zip file, and then I have to somehow mark the fact that I'm supposed to extract that. So what they do is they in the zip file itself, like a standard zip file, they say, I add a comment to entries that I want to unpack. So if you want an executable jar coming out from like Spring and Docker repo, well, you have to say, I'm recreating the same thing as you did. And at the end, I'm saying, oh, and by the way, your lunch script is here, so I pre-pen your file with the whole lunch script. And that's it, right? That's the way you can recreate the jar file out of like a Docker image. So, coming back, how to create. So let's say we know how to create like a good image, right? A good jar, let's say. But on top of it, how to create a good container, something running, right? Something that runs that image. Well, like the good containers are, the ones that start fast. It's not 5 minutes, not 10 minutes. Not that thing that you start and say, well, Tom got the starting, I'll just don't wait. It dies fast because that's also not something which happens regularly. It's like, oh, you have JMS, great. I'm going to wait 30 seconds until I'm sure I consumed everything I was supposed to do. I mean, so these are the problems that you meet when you're actually implementing those Spring Boot containers. And then like a good container is a friendly container. It says, hi, I'm using just that space I was supposed to use. All the other containers can come along, use my memory if I don't need it. That's also something that Java strives to provide. So, startup performance matters, right? I mean, if you have an application which throws 64,000 exceptions in startup, can that be fast? I mean, I don't think so. You know, like, okay, pet clinic, right? I mean, this is an example application. It starts on a fast machine like in 3.5 seconds, which is really good. I mean, come on, I was like 64,000 exceptions, 3 seconds, here you go. But at the same time, if you run that, you know, that's your machine, right? If you run that on some kind of a small, tiny instance, well, you're going to have issues, right? I mean, just please wait. That takes a minute to start, and then, you know, during that minute, things can happen. So, previously I showed you the example of like these 60,000, 4,000 exceptions, and, you know, I just summarized them, you know, how they look, and they look beautiful. I mean, so for what actually Spring Boot does, it says, I don't know what you have, but I'm going to check every single class if you're a bean factory, because, you know, you might be a class that provides new beans. So let's go ahead and just, you know, go through every single class. And then, oh, you have Ruby. Oh, that's great. That's thousands of new classes. Scala. Beautiful. And it's like, it takes time, you know, to scan. Like, and then, you know, on top of that, you have like a Spring Boot implementations of your own, like which, like it uses the auto configuration, which actually says, ask if that class is here, okay, so it means that the functionality is there. So you have a lot of, you know, asking for the JVM whether functionalities are there. This is, you know, this takes time. What can you do about it? There is like a nice GitHub repo where some guys actually took Spring Boot and they started like ripping it apart, like trying to find out what makes it faster. So, you know, they had an application which had like eCache, like I don't know, Guava or like whatever, you know, like a Vue framework, like I don't know, FreeMarker, like ThemeLeaf, or, you know, Jackson, for instance, for providing some kind of a, you know, JSON serialization, and they started like ripping that apart, you know, just trying to see, you know, if that would increase the speed of the startup. So, well, oh, it went out. Okay. So, you know, just read that website. They compare like different variants of like Spring Boot, and they say, you know, how it was in like in 1.5, how it was in 2.0, and so on. What kind of flags make a difference? Fat jars, thin jars, does it make a difference if you extract it? What about like features that you provide? Hardware, like if you run it on AWS, they summarize it all. You know, they're listing like different tickets that you're supposed to see, just to find out if it's supposed to work faster or not. How to make it faster locally, because it's, you know, I know every single, you know, I believe that probably everyone here tried to, you know, increase the, you know, the speed up performance, right? And then, you know, just connecting JProfiler and nothing shows up, and you know, because it's not simple. You know, you're supposed to also do that and see what's the outcome. One of the giveaways is actually that, you know, for instance, Jackson. I mean, just loading it up, that's 1 second usually, even on fast machines. So it makes a difference. Yeah, just summarizing how it started up on like benchmark results. Yeah, you know, like a Spring Boot application can start in like less 2 seconds, even like the not simple ones. But it's, you know, it's not, you know, it's not normal. Usually it takes tens, maybe more. And they have the results for, you know, Spring Boot 2, Spring Boot 1, so on, how it works, how Pet Clinic works, you know, when you start it up. You know, just take a look, like comparing like different, you know, different options. Something that you can take straight away, no strings attached. So I just go to the, just get there. Okay. So, one of the things that you can start immediately is those options. They came up with just like, you know, locally, just add those options in and your application would start much faster. Like for me, it means like 1 second. I mean, 1 second is a lot for me. And if, you know, if you think about like multiple applications which you keep constantly restarting, that makes a difference, right? I mean, all these options do is usually, you know, not verifying that the bytecode is correct, or, you know, just making the compilation simpler so that it's not that optimized. But it's really good for local development, just to, you know, just to keep it fast. let's just go back to the cluster. I just want to see how it's doing. Here you go. Which organization to use? My one-man army organization. Here you go. Creating like repos. Still repo, staging repo. For every single environment, we'll create a repository. It's like that approach for like DevOps, GitOps, how they call it. Yes, for production also use the same account. I mean, I'm just managing it all, like full stack development. And here you go. It's like it says, okay, after an hour of you waiting, it created that environment, which is really good. So what you can do, well, you can take the address of Jenkins, right? So it generated a new Jenkins environment. Then it will ask, okay, you're supposed to log in here and provide some kind of a fighter rust. I hope he's not describing anyone. Yeah, so he's right now just creating an environment for itself. So he's saying, okay, I need to build production environment, staging environment, and all the other standard environments, so that if you want to start up a project, this is a really nice way to keep it like standardized. But he's just creating Jenkins for you, and that's also not something simple. I mean, if you want to have like a way to provide Jenkins environment, which is distributed, it's really good. So let's get back to the presentation. So how to see what's going on. There are like different commands that you can use. Like Docker stuff is really good. It's like pop command for like Docker. You can see how much memory is used for like specific resources. So so that this guy uses 4 megs, and he's using like the network drive. I don't know exactly what, probably just 4%. Well, it doesn't look too good. But either way, like CPU is neglectable, so it says nothing. So if you run that command, you'll get like information what's going on. This is the fast way to actually say whether something wrong is going on. We use that daily, right? I mean, every person who actually does that, every person who does uses Docker. Now, if you want to use like a remotely debug Java application, you have to first forward a port to it. If you do that locally, you can expose the port. But if you're using like an orchestrator, it's not that simple. You're supposed to actually provide, first like connect SSH to something, then SSH again. And usually, like in Docker's world, we first have to go to the gateway, then you have to go to the manager, then from the manager you have to go to a specific worker, and then from the worker you have to go to a specific container, and maybe on top of it there's something more. But it's like it's a long path. Where here you can have a command which says, please forward me port 5005. From a container deep inside the cluster, and then peplin it, and then take that port and bind it to my local port 5005. It's like really good method to speed up your development if you want to remote debug. Now, another thing is stability. Okay, question is, who's using like Spring Boot application in like a zero downtime environment? Who's using it? All right. Okay, I like that blurry thing because I'm not sure if I use it zero downtime. Why? It's a funny thing, right? You have a framework which exists 5 years now, and there is a ticket open for really months now when someone says, hey, by the way, why do you stop your application in the wrong order where you kill the beans and only afterwards you say stop making accepting requests? It's like you have a zero, out of the box, you don't have a Spring Boot zero downtime application. Oh no, it doesn't work that way. It's like, okay, fine, it will create a new instance if you kill one, you make that graceful. But at the same time, what it will do, it will say, kill the beans, and then kill the Tomcat, Undertow, or like Jetty, whatever have you. And then you just see those 5,500s, like HTTP 500, just creeping out, and you don't know what happened. Well, that happened. I mean, and that, you would think that the framework like that should have that out of the box, but it doesn't. What you have to do is you have to provide your own way of doing that, there are like 4 different projects which deal with that. The bug is still open a long time, and people came up with their own solution. And their solutions aren't good at all. I mean, okay, what we do first, usually how that works is, I'm going to create a new endpoint, publicly available, which is, well, maybe you can secure that, but still, you see the problem already. And then that endpoint will say, kill the application. Okay, I'm not cool with that. Endpoint, HTTP endpoint, just kill my application, or so what Docker will do, it will say stop the stop the embedded container like Tomcat, accepting new requests, and then just afterward just kill the application itself. And that's mad. Things get interesting if you have like JMS attached to the application, right? I mean, it just makes it more complex because you have to think, okay, well, who dies first? I mean, just do we play a roulette? I mean, it's just not implemented. So that's that's a shock to me. So just keep in mind that if you have a zero downtime application, chances are you don't. So that Jenkins X. So let us see if it just finished. And he's yeah, he finished. Okay, so once you have that, he's really nice to me, and he's saying, oh, by the way, now you have your own CI environment, you have a beautiful Jenkins, like distributed. You don't have to worry now about CPU running out or memory running out. It's all in cluster now. So please execute that one command which says create a new Spring Boot application. Okay, I'll do that. And I'm saying at the same time, okay, this application is going to use features like web and actuators that provide health checks and so on. So let's see. He's asking for the language. Well, let's just keep it simple. Foxy. Okay, artifact. Foxier. Here you go. So he says, fine, I'm going to create a new project, and I'll use your private repository. If you don't override it, then we will say yes. Yes. So he created the files like some kind of a demo application, that you could use to override later. Commit message. Okay, that makes it cryptic already. And yeah, again, yes, my beautiful organization. Foxier, the repository name. Yeah, he's pushing that all to GitHub now. C3G, all working together beautifully. So you can go back to Jenkins and see that it actually, what it did is he's supposed to now, Foxier is scheduled. He's right now trying to create a new container, which will be actually a Jenkins agent, and he's right now created that application inside of GitHub, and he's going to build it all and deploy it to staging. So that's the default behavior it has. So it's really cool way of just keeping it simple, right? If you want to have a Docker container, it's out there. So as you can see, he created a new agent somewhere in the cluster, and now he's just building it. It will take a while, so let's continue. Yeah. So what to expect. So if you don't use Docker, well, start. If you're thinking I want to use Docker, but I don't know which orchestrator to use, pick one. I mean, Kubernetes is is right now has the edge. I mean, it had the edge since the beginning. It just was complex, but now you have a lot of tools which actually simplify the creation of clusters like that one. If you use Docker, test it, because you can die easily. Spring Boot applications die easily. And if you cannot use Docker because corporate rules, there is a separate team which knows what to do and so on, try it locally. I mean, it really simplifies the local setup that you can have, and and it works like a disease. You know, like once you have it, like locally running, and you say, well, you know, I don't care about your environment, it works beautifully with my Docker locally. You know, people start to say, well, I want to have it too, right? I mean, I don't care about production yet. I mean, I just want to keep it, you know, simple and working. And you know, if you have something nice, you know, some good configuration, just share it, you know, because there is always room for improvements. I mean, you know, along these slides, there are a couple of mistakes, like for instance, with images used, their sizes, their, you know, JDK used, with the JRE being the full-blown Debian Jesse image used behind it. You know, there are reasons for that, but you know, there's like a lot of quirks that you have to know, but you don't have to know them straight away. So Kahoot. Now we have to end the contest. Like as I mentioned, like the reward is a book called Docker Toolkit, and it's so fresh that it was released 2 weeks ago, and Amazon is not sending it yet, so I'll have to ship it to you. But Kahoot, back to Kahoot.
So here you go. Next question is, we have to find a winner. Okay. So, like Spring Boot, like it has like Spring Boot dependency project, which lists all the dependencies that it has, different libraries that it has, and with what does it integrate with. How many libraries do you think that is? I mean, is it like 50, 150, 300, 500? You know, how many projects is that? Why does it matter? It matters because you have to ask, okay, do I have this class? Do I have that class? And you know, you pay for all that. It's not for free. You get diabetes, really. Yes, and the answer was 150. You know, that's the answer. Okay, next question. What's the US JRE available now? Just, you know, choose a number. Any number is good. They're all fresh. Just for years, they weren't updated, and suddenly, outburst. Okay, yes, the answer is 11. Early access program. And it's beautiful. Okay. Next question is. Okay, we have a new person leading. What's the current version of Node.js? Because you have to know the environment. Yes, 10-0. Okay, 10-0. Okay, we continue. A couple of questions left. Let's check the cluster. Okay. Let's go back to the cluster. And it's still doing something. It's doing, oh yes, it's
Pushing to staging. So pushing to staging means creating a new pull request and then accepting it. I mean, it's creative, but you at least you keep track of what's going on, if you accepted it and so on.
good idea. That's, you know, GitOps in practice. Okay, you know, let's just wait for that with Kahoot. Some more Kahoot. Sorry. Okay,
Which command is used to actually find out what are the sizes of specific layers, like in Docker image? Yeah, Docker history. Okay. And the winner is Entaro. Nicely done. I'll come, if you could later on come back here, we'll settle that. Okay, so let me just see where am I? So if nothing else, I'll leave you with questions if you have any questions.
So how do you tag your releases? How do you tag your releases?
Oh, that's an interesting question. I didn't mention that, right? Okay, yeah, I'll mention that. So let me just see that guy here. Fail. Yeah, let's just wait. I'll blame it all on GitHub. So we want to have, like usually locally, the same thing as we do on production and like development. So what we do every single time a release is of a specific like one component is being created, we tag it in Git, and then someone can pull the latest definition of like Docker Compose, and he has it locally installed, right? I mean, he just says Docker Compose or like Docker Swarm update, and then he has the latest version of that application. And it's really good way of actually keeping track of what is installed, because you can have like multiple environment like setup, and at the top on top of it like like having different variants for customers kept really nicely. Any other questions?
Yeah, but that means like you have actually a tag created for every push, right?
Yes, we do. We
Okay,
just
so, and if you wanted like you want like your development is ongoing and you want to go back to the version that is currently in production, so how you do that? I mean it's doable because probably some
definitely. Well, you can just you can change the you can say git like a git checkout from a git tag which specifies that specific release for that Docker Compose file, and that will get you there.
Alright, because production can tell what's done.
Every single variant is actually specified that way, so you can move back to it if you want to. Okay, so he finished, and when he finishes, he says your application is available here. So you can see it works because it throws an error message, because there is no controller there for the standard application. You just have to fill that yourself. But that's working. Workish. What you get is the fact that you can say applications. You can say, okay, what are the applications that I have in the system? And it tells you, for instance, that you have in staging version 001 of Boxier. The URL is here. If you're satisfied with it, you have some kind of a testing job for Jenkins. You can say JX promote version 001 and production Boxier, right? So version. So what that will do is it will actually make a pull request to the repo of production for that for that environment, and it will push those changes and then create like the like a new version of production for that application. It's really simple way to keep started to start with Docker and to Kubernetes completely remotely with a nice setup for Jenkins. All right, any other questions? Well, in that case, I mean, if you have any questions, you can come along here, and I would like to thank you very much for coming. Thanks.
Dzięki wielkie, Rysiek. Jeszcze minuta, dwie wylosujemy jak zwykle do wyboru. Albo wejściówkę na warsztaty stacji IT, które są organizowane w całej Polsce, albo licencję do IntelliJ ID. Jak się podłączy? Użyjemy jak zwykle naszej oficjalnej aplikacji losującej. Zapisało się na etapie 160 osób prawie. Próbujemy znaleźć jakąś osobę, która jest rzeczywiście. Czy jest z nami Kuba? Kuba Korzeniowski. Kuby nie ma. Czy jest z nami Maksymilian? Nie ma. Aha, dobra, oczywiście. Czy jest z nami Arkadiusz? Dobrze. Is there Tommy here? Is there Paweł? Czy jest z nami Paweł? Okej. Marcin? Dalej nie? Ciężko jest. Bartek jest z nami?
Jest.
Jest? Dobra. Bartek zgłosi się do mnie zaraz, po prostu ustalimy sobie. Dzięki wielkie jeszcze raz i do zobaczenia za tydzień.